Hi, welcome to another lesson about memory. This time we are going to talk about defining memory. Let's look at the first example, simple data def.asm. We can see that we have 4 data definitions in this file, but maybe the most surprising thing about this file is that actually it doesn't contain all the usual syntax that we can see in assembly files. For example, we don't have the format PE and all those sections. Actually, this file doesn't contain anything besides of the definitions of the data. You might be wondering if this is possible at all. Well, it is. The FASM assembler has this name because of its ability to create those kind of flat files, just like this file. The FASM means flat assembler. So actually we can create a file which is not executable. The operation system is not going to be able to understand how to run this file or how to load it to memory, but it will actually allow us to create any file that we want. We have full control over the resulting file. Let's talk about the data definitions that we can see here. The first one is called A. Actually, if we ever want to refer to this data, we will use the name A. A is some kind of a label. Next we have this, DB, which means data byte. And then we have this number, AB, in base 16. So actually this is just a definition of 1 byte. This byte is going to reside inside the executable file. The next definition is of a word. The name of this definition is B. This is the label that points to this word. And then we have this operator, data word, DW. And the value is CC99. I remind you that word is just 2 bytes together. Next we define a double word, which is of size 4 bytes. We can see here the name C, and then DD, which means double word, and finally this number. This is actually a number of size double word, 4 bytes. Finally, we define a quad word with the name D. D, data quad word, and then this very long number, which is of size 8 bytes, or maybe 64 bits if you want. So, we have defined those 4 structures. Let's take a look at the file that is produced when we assemble this. Okay, we got as a result a file of size 15 bytes, which is pretty small. Usually we get much larger files. Let's take a look at the inside of this file. And maybe first we can try to run it, and we can see that the Windows operation system doesn't understand how to run this kind of file. However, you can open it with your Hex editor. I'm going to use Hex Workshop. Okay, so this is the result. Let's take a look at the result against the source code that created it. So let's begin with the first byte, AB. It actually corresponds to the definition of A. A is just 1 byte which contains AB. So actually A points here. Next we have CC99, and we can see it inside the file, but in the opposite direction. This is the little endian convention. All that you have to remember about this convention is that whenever you write CC99 inside your source code, you are going to see it the other way around when you open it with an Hex editor. For example, I wrote CC99, and here I have it the opposite direction, 99CC. Let's move on to the next definition of the double word. The double word is 1, 2, 3, 4, 5, 6, 7, 8. We can see it here as 78563412. So the 4 bytes are reversed with respect to this representation. Next we have the quad word definition, which is pretty large. And maybe not very surprisingly, it is stored the other way around when we look at it with the hex editor. We can see that it begins with 44 and it ends with AA. So it goes the other way. It goes from here, from 44, all the way to AA. We can see that we created a very flat file. It only contains the data that we wanted. And we had full control of the data in the resulting file. Let's look at the next example, multi-data. Here we are going to talk about the dupe operator, at least in a basic way, and how we can define a set of consecutive bytes, or maybe words or D-words. This is usually something that you are going to do in your code, because usually you are going to want to have lots of data. You don't usually just want one D-word. You will sometimes, but not always. So let's take a look at how to do it. For example, this first definition is about defining 4 consecutive bytes, which are of value 12. How do we do it? First, we choose a name. Here we chose the name array bytes. And then we choose the size of each element, which is data byte. Next, we use the dupe operator. The dupe operator works the following way. First, you put a number, which means how many repetitions you want to have. Here we want to have 4 repetitions. Next, we have the dupe operator. And finally, we have the number that we want to repeat. I even think that sometimes you can just discard the braces here, but I'm going to use them just to make sure that nothing bad happens when you try more advanced stuff. So actually, this is going to produce 4 consecutive bytes of the value 12. Another example, here we use the data word. So here we have 5 data words of value 5, 6, 7, 8. We have here another 2 examples. This one is about 6 consecutive D words of the value AA, BB, CC, DD. And finally we have a very large example of 7 consecutive quad words of this value. This is how we write it. I remind you again, we have the dupe operator and we have numbers on both sides. On the left we are going to have the number of repetitions, and on the right we are going to have the actual value that is being repeated. And before using this dupe operator, we have to specify the size of one element, which here is data quad word, actually 8 bytes. Let's try to assemble this example and see the result. Okay, this time we got a larger result, 94 bytes, which is quite a lot. We managed to create a pretty much large file using only those small definitions, which is pretty cool. It means that we have lots of power with those definitions. Let's open the file in Hex Workshop and see what is it like. We can see it here. Okay, so this is the resulting file. First we can see the 4 consecutive bytes of 12. We can see them here in the beginning. It corresponds to this definition. Next we have these words of 5, 6, 7, 8, but we have them the other way around. 5, 6, and then 7, 8. And this pattern is being repeated 5 times. We can see it here. It is being repeated 5 times. The next pattern being repeated is this one, which is originally AA, BB, CC, DD. We just see it reversed here. And this one is being repeated 6 times. We can see it here. And the next pattern is the quad word, which is this value, 9, 9, 9, 9, and then the 6, and finally the 8. We can see it here. These are 7 consecutive repetitions of this quad word. We can actually see it here in the text mode, in the ASCII mode. Okay, so this is about using the dupe in a simple way. I want to show you something a bit more advanced about the dupe operator. It might be useful for you. Let's look at those data definitions in the file moredupe.asm. Those are a bit more interesting. You can actually repeat a sequence. For example, here, I can repeat this sequence of bytes 4 times. I don't know about you, I think it is really cool that you can actually do it. The result is going to be 5 times 4, which is 20 bytes. The result is going to be 20 bytes because we repeat this pattern of bytes 4 times. The next example is about repeating a sequence of words. So instead of writing data byte, I use data word, and then I repeat 3 times this sequence. Don't be mistaken by looking at this example to think that 6 is only of size byte. It's not true. The size of 6 is going to be determined by this keyword, by the data word keyword. So actually, 6 is going to look like this, 0006. And also 7 is going to look like this, 0007. And this pattern of 2 words is going to be repeated 3 times. So let's count the number of bytes that we are going to finally have. We have 2 words, which is actually 4 bytes. And those 4 bytes are being repeated 3 times. So actually, we are going to have as a result 12 bytes. Let's look at the last example, which is also pretty interesting. This example shows that we can do arithmetic here. The FASM assembler is pretty interesting. You can do some really interesting things. For example, you can multiply things here. And the assembler is going to first multiply it, and only then it will go over this word definition. So for example here, we actually define this double word 6 times. 6 is just 3 times 2. It is not very advanced, but I just wanted you to know that you can do those kind of things. You can write arithmetic here inside this line. A fast look on the result from this file. Let's first assemble it. And now let's take a look at this file. We can see the result here. First we can see the 5 consecutive bytes, which is 1 to 5, and this is being repeated 4 times. We can actually see it here. It repeats 4 times. Next we have those words 6 and 7 being repeated 3 times. And we can see it here. This pattern is repeated 3 times, exactly. Next we have this D word, ABCD 1, 2, 3, 4, which is being repeated exactly 6 times. And as usual, it is in the opposite order because of the little endian convention. We can see it here. This is basically about defining data and using the do operator. I think that for most of your programs, this is what you are going to need. Next, we are going to talk about sections and how to define them, but this is going to be in the next lesson. See you next time.